Hello, in this video we're going to go through the exercise from class, pretty and prime. Now I've written a solution, it's slightly modified from the one we did in class for some specific purposes, but we want to make sure we can follow through this and highlight the important structural pieces that we're putting in place. So what our program is going to do is it will take an input for an integer, and that input needs to be between 2 and 999 inclusive. Once that input is taken, the program will determine if the number is prime or not, and then output accordingly. So just a reminder in terms of what a prime number is a prime number is a number that is only divisible by 1 in itself. So for example, 13 is prime, but 12 is not prime because 12 can be divided by 2, 3, 4, 6. Okay, so if we take a look at this program here, we're going to break it up into larger chunks. The first thing we do here is we take our input. The second thing we do is we determine if the value is prime. And the third thing we do is we output based on if the value is prime or not. Okay? So we come to the top. Let's first start by looking at our variables. And we declare a scanner class, and then we declare this Boolean variable called isPrime. This tells the computer or stores if number is prime or not. And so true means the value is prime, and false means it is not prime. Now here we've initialized it to true, and the reason is that I'm going to assume every number is prime unless I find a number that can divide it evenly. So in other words, if we take the number 12, I'll assume 12 is initially prime, and then I'm going to walk up starting from 2 up to some number and check each time. So I'll say to myself, well, is 12 divisible by 2? So can I take 12 divided by 2 and get no remainder? And of course we know the answer is yes, we get 12, 0. And so as soon as I see that 12 is divisible by 2, I know that 12 is not prime, so I'll change this Boolean from true to false. N is my input variable, and CTR this is my counter. So I'm going to use this counter to kind of walk up to check all the numbers. So we're going to start at 2 and then work our way up to, but not including the actual value of n. Check. Of values. Okay, so first thing we do here is we have a do while loop. I use this do while loop here because I have to take at least one input. So what happens is that I have to ask the user once to input a number, so a do while is a nice choice here. Of course I could use a while loop, and a while loop would be perfectly functional, but a do while is often used when we have to ask the question at least once. So this is where we take our input, and now this is a little bit of logic. Logic to indicate user an invalid number. Enter. And then down here at the bottom, this is the end of my do while loop that stipulates the logic. So it says I want to keep asking this question as long as the value of n is less than or equal to 1 or greater than 1,000. And actually my initial statement for this was incorrect, because based on my logic there, this right now will actually take an input of 1,000. So let's just show that. So if I put 1,000 into this, it will work. So I said at the start I want my program to go from 2 to 999, so I have to say greater than or equal to. So now if I run it, let's try this open a little bit, and I put 1,000. Oh, that's 100. Let's start this again. Let's put 1,000. It asked me to input something again. Perfect. Okay, so let's come down here. So now we understand how we take our input. And once we've taken our input, then we're going to determine if the number is prime or not. So I have a while loop now, and while does two things. It checks if isPrime is true, because I want to keep checking as long as isPrime is true, and it makes sure CTR is less than num. So what I'm going to do is, let's take the number 13 for example. I want to check if 13 is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now this is not the most efficient approach to this, but for this approach, I want to start by saying, is 13 divisible by 2? Is 13 divisible by 3? Is 13 divisible by 4? And if I find at any point as I go through this process, 13 is divisible by a number, I know that it is in fact not prime. So what I do in here is, inside the while loop, notice there's no outputs to the screen. This is purely just logic. What I'm doing is checking to see if it's prime or not, and then setting is prime appropriately, and then making a decision later based on is prime. So if I come in here, and let's imagine that n is 13, I'm going to say is 13 mod 2 equivalent to 0. Remember, modulus gives the remainder. So if I say is 13, if 13 is divisible by a number, the remainder is 0. So the minute that I show that the number is divisible by the minute I show that n is divisible by a value, I set is prime to false. And of course, each time I have to increase CTR to check the next number. So again, let's just talk about this while loop here. So this chunk of code here is the code is used to check if the number is prime or not. So I come in, and of course the number is initially assumed to be prime, and CTR is initially set to 2. So what happens is we come in and we say if n mod CTR is equivalent to 0, so we're checking if the number is divisible by a value, which is stored in CTR, and then if it is divisible, we know that the number is not prime, so we set is prime to false. And then we have to increase CTR by 1 each time because we want to work our way up. So over here in this diagram, if we have the number 13, we have to check 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so this is the final part of our code, and the final part of our code is we check the state of is prime and then output accordingly. So Booleans are really useful if we want to remember something to be used later on in our program. So I hope this is helpful, and I hope we follow along. I'm going to do one last thing with this program. I'm going to modify this program so that give the user the opportunity to ask this question again and again. So essentially, right now, if I run this, what happens is it says input a number to check. I input, say, 97, and it says number is prime, and therefore it's done. But what if I wanted to ask me again without restarting the program? Well, to do this, what I'm going to do is I will put this entire program inside a while loop. And I'm going to have a new variable, a char variable called again, and we're going to make that equal to y. So we're going to say while again is equivalent to y, or again is equivalent to capital Y. I'm going to open a brace. I'm going to highlight this entire, everything down to there. Let's actually enlarge this to the full screen. And this is the end of the while. So right now what happens, let's just pull this back, is what we've done is we've taken the entire chunk of code and put it inside of a while loop, because that means the program is going to loop over and over again. Oh, there you go. Sorry, this is the end of the while. This is the end of the main. And this is the end of the class. So if I run this right now, what's going to happen is it's going to pop up and say input a number to check. Let's check 2. 2 is prime, and then it comes back to the top again. So it comes down here, and then it gets to the bottom, and since again is y, it goes back to the top and runs through the whole program again. So this will go on forever, but you'll notice something funny, or some funny behaviors can start to happen. So if I put in 6 and it says 6 is not prime, and then I put in 2, notice how it's telling me that 2 is not prime now. So there's some weird behaviors happening. So there are two things we have to do here. We have to give the user an opportunity to exit this program, and we have to account for this kind of odd behavior here. Let's start by addressing this odd behavior. And again, that odd behavior is that if I continually type in 2, it's 2 is a prime, 2 is a prime, 2 is a prime. The minute I enter 6, it tells me that 6 is not a prime, which is correct. But then if I enter 2, it tells me 2 is not a prime, which is a problem. This is an issue of reinitialization. So remember at the start of the program, I set all of these values in a specific manner? I need to reset them back to those values again such that the program can do the calculations accordingly. So what I'm going to do is at the very end of this, I'm going to set is prime to false again. Sorry, is prime to true again. I'm also going to set CTR to 2 again. And those are the two in this case I have to change, because if I go back up to the top after I've changed is prime to false, that changes my logic. So now if I run this program, input a number to check. Let's check, say, 5, and it says 5 is prime. Now if I put in 9, 9 is not prime. And notice, now it actually works with the multiple values because I have to reinitialize these values at the bottom. The second problem we want to fix is we want to be able to take an input from the user to actually ask them if they want to do the program again. So I go system.out.print. Would you like to enter another number? And then I'm going to say again is equal to s.next.char at 0. So now if I run this, input a number to check, let's check 5, number is prime, would you like to enter another number? Here I am here, and I put yes, I go back to the top, let's put 87, 87 is not prime, would you like to enter another number? I put n, and then my program ends. One last little thing I might want to do is when my program ends, I might want to prompt the user so they know. Come again. So this program highlights a lot of ideas, and this pretty much summarizes what we've done in our first reporting period. I really want to stress the importance that you can go through this and work through and understand this code. If you have any questions, of course, feel free to ask.